Hi, welcome to DBMS course. In this session, we will discuss about how to find candidate keys by using a set of functional dependencies on a relation. So let us start the session. First, let me revise the definition of a candidate key. What is a candidate key? A minimal set of attributes which can uniquely identify the records of a relation. Then, how to find such minimal set of attributes? For that, what we do is we find minimal set of attributes whose attribute closure contains all the attributes of the relation. Let me explain this with an example. Suppose we have a relation with four attributes A, B, C, D, and the functional dependencies A implies B, B implies D, D implies C, and B implies A. First, let us give numbering to the functional dependencies so that it will be easy for us to use them. Fine. What are the attributes for this relation? The attributes for this relation are A, B, C, D. Now the first step is we need to identify whether there is any attribute which is not present on the right hand side of any functional dependency. If an attribute is not present on the right hand side of any functional dependency, then we cannot derive it by using other attributes. So we must include such attributes in our candidate key. So first let us verify it. Now A is present on the right side of 4 and B is present on the right side of 1. C is present on the right side of 3. D is present on the right side of 2. So every attribute is present on the right hand side of some functional dependency. So no need to include any attribute compulsorily. So let us start with the minimal set of attributes. First we consider sets with one attribute. So this is our first one. What about second one, sir? What about third one? Set with C. What about 4? Set with D. Let us find the closure of A. With the A, I can get A. By using 1, I can get B also. Now I have A comma B. By using 2, we can get D. Now we have A, B, D. By using 3, we can get C. We got all the attributes. So the set with A is a candidate key. What about the closure of B? With the B, we can get B. Then by using 2, we can get D. By using 3, we can get C. By using 4, we can get A. We got all the attributes of the relation. So B is also a candidate key. What about closure of C? With the C, we can get C. Anything else? No. So we are not getting all the attributes. So the set with C is not a candidate key. What about the closure of D? With the D, we can get D. By using 3, we can get C. Anything else? No, we cannot get any other attribute. So we got only 2 attributes. So D is also not a candidate key. From the first stage, what are the candidate keys? A is a candidate key, B is a candidate key. So when we form supersets of the attributes, we should not include these 2 attributes, because if we include these 2 attributes, that supersets cannot be the minimal set of attributes. So then what are the attributes which are not candidate keys? C and D. So let us consider only these 2 attributes to form the attribute set with 2 elements. The one and only set which is possible with these attributes is C comma D. What is the closure of C comma D? With the C we can get C. With the D we can get D. Anything else? No. So we are not getting all the attributes. So this is not a candidate key. Now the next step is, can we form a 3-element attribute set by using only these 2? It is not possible. So 3-element attribute set is not possible. So these are the only candidate keys. What are the candidate keys, sir? A and B. These are the only 2 candidate keys for this relation. Is that clear? Let us do one more example. Suppose we have a relation with 5 attributes A, B, C, D, E, And the functional dependencies are A implies B, B implies E, E implies C, B implies A, and D implies C. First, let me give numbering 1, 2, 3, 4, 5. What is our first step, sir? Verify is there any attribute which is not present on the right side of any functional dependency. A is present on the right side of 4. B is present on the right side of 1. C is present on the right side of 3. Then D is not present. E is present on the right side of 2. So the attribute D is not present on the right side of any functional dependency. So we must include the attribute D in our candidate key. So first what we do is we form a set with attribute D and verify whether it is a candidate key or not. If it is a candidate key, it is the only possible candidate key for our relation. So let us verify it. What is the closure of D? The D we can get D. Anything else? By 5 we can get C also. Then we are getting only 2 attributes. So we are not getting all the attributes. So this is not a candidate key. This is not a candidate key. So now we consider minimal set of attributes which include the attribute D. So what is the first one, sir? I can consider D comma A and D comma B, D comma C, D comma E. Let us find the closures of these sets. What is the closure of DA? With DA we can find D comma A for sure. Then by using 5 we can find C. By using 1 we can find B. By using 2 we can find E. So we got all the attributes. So D comma A is a candidate. Then what is the closure of DB? With D we can get D. With B we can get B. Then anything else? With B we can get A. By using 1 I can get B. B already we got, sir. By using 2 we can get E also. Then by using 3 we can get C also. We got all the attributes. So this is also a candidate key. What about the closure of DC plus? With D comma C we can get D comma C. Now anything else? No. We are not getting all the attributes. So this will not be a candidate key. What about the closure of DE plus? DE. Then with the E we can get C. With the C nothing is possible. So this is the only attribute set we are getting. So we are not getting all the attributes. So this is also not a candidate key. From the first stage, what are the candidate keys? D, A, D, B. Now, what are the attribute sets which are not candidate keys? D, C, D. For the next stage, that is to form 3-element attribute set, we need to use only these attributes, and in those sets we must include D. So then what is the possibility for 3-element subset? This is the only possibility. Now let us verify whether this is a candidate key or not. So find the closure D, C, E. Fine. Now anything else? No, sir. We are getting only 3 attributes. So this will not be a candidate key. So the only possible candidate keys for this example is DA, DB. Is that fine? Let us do one more example. Suppose we have a relation with 6 attributes A, B, C, D, E, F, and the functional dependencies are D implies A, E implies F, B implies C, F implies D. Let us give numbering 1, 2, 3, 4. Fine. Now A is present on the right side of 1, B is present on right side of 4, C is present on right side of 3, D is not present, E is not present, F is present on right side of 2. So the attribute D comma E are not present on the right side of any functional dependency. So we must include these 2 attributes in our candidate key. So what we do first? We verify whether the set with only these 2 attributes is a candidate key or not. If this is a candidate key, this is the only possible candidate key for our relation. So let us verify it. With D, we can find D. With E, we can find E. Then by using 2, we can find F. Then by using 4, we can get B. By using 1, we can get A. By using 3, we can get C. So we got all the attributes. So this is a candidate key. This is a candidate key. Since DE is a candidate key, no 3 element set or 4 element set or 5 element set or 6 element set cannot be a candidate keys, because those sets must include these two attributes. Since this is already a candidate key, those sets cannot be the minimal sets. So that's why they cannot be candidate keys. Is it fine, sir? The next example. Suppose we have a relation with 5 attributes A, B, C, D, E, and the functional dependencies are A implies BC, CD implies E, B implies D, E implies A. So let us give numbering 1, 2, 3, 4. Then A is present on right side of 4, B is present on right side of 1, C is present on right side of 1, D is present on right side of 3, E is present on right side of 2. So every attribute is present on the right side of some functional dependency. So we can start with minimal set of attributes. So first let us consider the attribute sets with one attribute. A, B, C, D, E. What is the closure of A? With A we can find A. By using 1 I can find B, C also. Then by 3 we can get D also. Then by using 2 with C comma D we can get E. So we got all attributes. So this is a candidate key. What is the closure of B? With the B we can find B. With the B we can find D. Anything else? No. We are getting only 2 attributes. So this will not be a candidate key. What about closure of C? With the C we can get C. Anything else? No. So this will not be a candidate key. What is the closure of D? With the D we get only D. So this is not a candidate key. What about closure of E? With the E we get E and we get A. Then with A we can get B comma C. By using 3 we can get D also. So we are getting all the attributes. So this is a candidate key. So what are the candidate keys from the first stage? The candidate keys are A comma E. So what are the attributes which are not candidate keys? We have B, C, D. Now we need to form 2 element sets by using only these 3 attributes. What are the possibilities? BC, BD, CD. What is the closure of BC plus? With B comma C we can get B comma C. Anything else? With B we can get D. Then by using C comma D we can get E. By using 4 we can get A. We got all attributes. So this is a candidate key. What about closure of BD plus? With B comma D we can get B comma D. Then nothing else. So we are not getting all attributes. So this will not be a candidate key. What about closure of CD plus C comma D? With C comma D we will get E. Then with E we can get A. With A we can get B. So this is a candidate key. I mean C comma D is a candidate key. So what are the candidate keys from second stage? B, C, CD. Right, sir? Now from the second stage we have 2 attributes B comma D. Now can we form any 3 element set by using only three attributes? These 2 attributes. It is not possible. So these are the only possible candidate keys for this relation. Is it fine? Let us do one previous question. Let R equal to A, B, C, D, E, F be a relation schema with the following functional dependencies. C implies F, E implies A, EC implies D, A implies B. Then which of the following is a key for R? This is very easy, sir. For every option, find the attribute closure. If the attribute closure contains all the attributes of the relation, then that option is our key. So these are the functional dependencies they given. 1, 2, 3. Okay. So we can verify each and every option directly. Okay. Before verifying, if you verify whether there is any attribute which is not present on the right side of any functional dependency, it will reduce some of our work. So first let us verify what are the attributes A, B, C, D, E, F. Now A is present on right side of 2, B is present on right side of 4, C is not present, D is present on right side of 3, E is not present, F is present. That means in my candidate key I need to include these two, C comma E. Now please go to option A. I have C but I don't have E, so this cannot be a candidate key because the candidate key must include C comma E. Maybe some more attributes, but these two are mandatory. What about E comma C? I have these two attributes. So let us verify option B. EC closure or CE closure. With E comma C, we can get E comma C. Now by using 2, I can get A. Now by using 4, I can get B. Now by using 3, we can get D. By using 1, we can get F. We got all attributes. So E comma C is a candidate key. So option B is our answer. Is that fine? The next question. Consider the relation schema R with attributes E, F, G, H, I, J, K, L, M, N and the set of functional dependencies EF implies G, F implies IJ, EH implies KL, K implies M and L implies N on the relation R. What is the key for the relation R? These are the functional dependencies they given, sir. So let us give the numbering 1, 2, 3, 4, 5. What are the attributes we have? E, F, G, H, I, J, K, L, M, N. Now E is present on, no sir, E is not present on the right side of any functional dependency. F, it is also not present on the right side of any functional dependency. G is present on the right side of 1. H is present on, no, it is not present anywhere. Then I is present on right side of 2, J is present on right side of 2, K is present on right side of 3, L is present on right side of 3, M is present on right side of 4, N is present on right side of 5. So these three attributes are not present on the right side of any functional dependency. So our candidate key must include these three attributes. We may need some more extra attributes, but these three are mandatory. So the option A does not include all the three. This is not our answer. Option B does not include all the three. Option C includes these three. So that may be true. So we need to verify it. So let us try option C. What is the closure of E, F, H? With E comma F comma H, we can find E, F, H. Then by using 1, I can get Z. By using 2, I can get I comma J. By using EH and third, we can get K comma L. Then by 4, I can get M. By 5, I can get N. We got all the attributes. So E, F, H, these are enough to find all the attributes. So this is an example of a candidate key. Since EFH is a candidate key, this superset of EFH cannot be a candidate key because this cannot be the minimal set of attributes with the property. Is that fine? Let us do one more question. Consider a relation schema R with 6 attributes A, B, C, D, E, H on which the following functional dependencies hold. A implies B, BC implies D, E implies C, D implies A. what are the candidate keys for the relation? So these are the functional dependencies we are having. Let us give numbering 1, 2, 3, 4. Fine. What are the attributes? A, B, C, D, E, H. A is present on right side of 4. B is present on right side of 1. C is present on right side of 3. D is present on right side of 2. E, H. These are not present on the right side of any functional dependency. So our candidate key must include these two. We may need some more attributes, but these two are mandatory. Coming to option A, I have E, but I don't have H. Coming to option B, we don't have H. Coming option C, AEH, this may be. BEH, this may be. But BCH, I don't have E. So surely this will not be. Even these two are candidate keys. This will not be a candidate key. So no need to verify option C also. It will not be correct. What about option D? AEH, BEH, DEH. Since all the three options are ruled out, this will be our answer. For safe side, let us verify whether all these are candidate keys or not. What is the closure of AEH? With AEH, we can find AEH. Then with 1, I can find B. Then with the E, we can get C. With 2, we can get D. We got all the attributes. So this is a candidate key. What about second one? BEH. With BEH, we can get 3 attributes. Then with BEH, with E, we can get C. With BC, we can get D. With D, we can get A. So we got all attributes. This is also a candidate key. What about next one? DEH. With DEH, these are for sure. Then by using 4, we can get A. By using 1, we can get B. Now, by using 3, we can get C. We got all attributes. So this is also a candidate key. So option D, all the 3 are candidate keys. So this is our correct answer. Is that clear? The next question. Relation R has 8 attributes A, B, C, D, E, F, G, H. Fields of R contain only atomic values. F equal to CH implies G, A implies BC, B implies CFH, E implies A, F implies EG. Is a set of functional dependencies, so that F plus is exactly the set of functional dependencies that hold for R. How many candidate keys does the relation R have? So for this type of questions, we need to verify all the possible candidate keys. In the previous 3 questions, they given simply the options. So it is enough to verify which of the options are a candidate keys. But here we need to find all the possible candidate keys and we need to count the possible candidate keys. So what are the attributes? So before going to attributes, these are the functional dependencies. 1, 2, 3, 4, 5. What are the attributes for this example? A, B, C, D, E, F, G, H. Now A is present on right side of 4, B is present on right side of 2, C also 2. Then D is not present. Then E is present on right side of 5. Then F is present on right side of 3. Then G is present on right side of 5. Then H, right side of 3. So D is not present on the right side of any functional dependency. So we must include D in our candidate key. So first let us verify whether D on its own is a candidate key or not. What is the closure of D plus? With the D we can get a D. Anything else? No. So we are not getting all the attributes. So D is not a candidate key. So let us verify 2 element attribute sets which includes D. What are the 2 element attribute sets? D comma A, D comma B, D comma C, D comma E. Then D comma F, D comma G, D comma H. Let us verify each of them one by one. closure of DA, DA, then with A I can find BC, then with B we can find C, F, H, then with F we can find E, G. I think we got all the attributes. So this is a candidate key. What about closure of DB? DB for sure. Then with B we can get C, F, H. Then with F we can get E comma G. Then with E we can get A. We got all the attributes. So this is also a candidate key. What about DC closure? DC. Then nothing is possible. So this cannot be a candidate key. What about closure of DE plus DE? Then with E we can get A. Now no need to continue the question, sir, because please verify D comma A. With D comma A we got all the attributes. So we can get all the attributes. So this is also a candidate key. What about closure of DF plus DF for sure? Then with F we can get E and G also. Now we have D comma E. DE is also a candidate key. So no need to continue. We will get all the attributes. So this is also a candidate key. What about DG plus DG for sure? Then no other attribute is possible. So this is not a candidate key. What about this DH? D fine, H fine. Anything else? No. So this is not a candidate key. So from the first stage, what are the candidate keys? DA, DB, DE, DF. So these are the candidate keys with two element sets. What are the attributes which are not part of candidate keys? I think DC, DG, DH. So these attributes we need to consider to form three element attribute sets and verify whether they are candidate keys or not. DC, DG, DH. So let me continue in next slide. DC, DG, DH. What are the three element subsets? D is mandatory. So DCG, DCH, DGH. What is the closure of DCG plus DCG? Fine. Then nothing is possible. So this cannot be a candidate key. What about closure of DCH? DCH. CH. With CH I can find G. Then no other is possible. So this cannot be a candidate key. What about here? DGH. So with DGH we can find DGH. Then anything else? With G, no other is possible. So we don't have any candidate key with three element sets. So now let us try with four element sets. With these attributes, what is the possible four element sets? D, C, G, H. So let us verify the closure. D, C, G, H. Anything else? With CH we got G. G is already there. Then nothing is possible. So we are not getting all the attributes. So this is also not a candidate key. What are the possible candidate keys, sir? We have only 1, 2, 3, 4. So 4 is our answer. Is that clear? So this is about finding candidate keys by using set of functional dependencies. In the next session, we will discuss about equivalence of functional dependencies. Thank you.